Okay, previously we worked example problems where we analyzed different sinusoids and determined their amplitude, period, frequency, and angular frequency. And in another video, we also sketched the sine and cosine curves from scratch in full detail. Okay, and so now what we're going to do in this video is we're going to do quick sketches of sinusoids. So the sketches aren't going to be as detailed, but we're going to be able to sketch them much quicker. Okay, and I stated previously in this section, we're focusing on sinusoids that haven't been shifted left or right or up or down. Okay, and so to do these quick sketches, we're going to take advantage of a property of sinusoids. So a sinusoid is either a sine or a cosine curve. We're going to take advantage of the property of sinusoids that, so let's draw a period here. Let's say this is sine. So there's a period P. Okay, the x-intercepts in the peak and the trough. So every period has, you can think about, it looks like 3 x-intercepts, but really you would say it has 2 x-intercepts because you would include one of these x-intercepts, like maybe you'd say this x-intercept is part of the next period, or this x-intercept is part of the previous period. So it has 2 x-intercepts and a peak and a trough. Well, for any sinusoid, even if it's been stretched about the y-axis, shrunk, stretched about the x-axis, flipped, whatever, and even shifted left or right or up or down, because shifting doesn't change the shape at all, right? So any sinusoid, no matter how it's been transformed, the x-intercepts and the peak and the trough are going to be equally spaced across the period. And so what we can do is we can take the period, divide it by 4, and now we know the x-coordinates of the peak and the trough and the x-intercept in the middle. So all we need to do is analyze the equation to get the period, like we did in the previous video, getting the period, the frequency, etc. of the sinusoids. Divide the period by 4, and we have the x-coordinate locations of each of these features. Now, then we also analyze the function like we did in the previous video to get the amplitude. And when we get to the peak of the trough, the y-coordinate is just going to be the amplitude. So we can plot the peak and the trough, plot the x-intercepts, and then use those points to do a rough sketch of the sinusoid. Okay. So let's say this is 2 pi. This is minus 2 pi. Okay, let's say it's 1 minus 1. Okay, so we see here, this is a cosine function that has been stretched about the y-axis. So this is by a factor of 2, so the amplitude is 2, and then the period hasn't been changed, so the period is just 2 pi. Okay, so we have a cosine function, untranslated, left or right, and so we know the cosine function at the origin is going to be 1 or minus 1. Well, here there's been no flipping applied, so it's going to be 1 here. That's going to be one of the peak points, and then it's going to come back to the same position at the end of the period, so it'll be here. Oh, well, no, that's not right. The amplitude is 2. Okay. So the amplitude is 2, period 2 pi. Okay, so we start here and we end here. Okay, and then 2 pi divided by 4 is pi over 2. So let's see, 1, 2, 3, 4, 5. There's going to be pi over 2. 3, 4, 5. There's going to be 3 pi over 2. So the main features are going to be at these quarter points. So we're going to have an x-intercept here and an x-intercept here, and then we're going to have a trough at -2. So I mean, there's really like 5 points to sketch the graph, but I guess technically though, one of the endpoints you consider part of the other period or the previous or the next period or the previous period. Okay, and that's it. With those 5 points, sketch the curve. Okay, now to apply the sketch in the -2 pi to 0 region, we're just going to copy and paste this curve. I mean, I like copying and pasting like that because it gives you a good feel for what periodic means. That's what you're literally doing. You're just copying pasting the period over and over and over again to plus or minus infinity. Okay, and then the frequency is 1 over the period. So 1 over 2 pi, which makes sense. 1 cycle for every 2 pi. And then the angular frequency is, so to go 1 cycle, it's 2 pi radians. So 2 pi divided by 2 pi is just 1. Okay, let's sketch this. Now, before I draw the axes, the size of the scale of the axes, let's look and see what the period is and the amplitude is. So here the amplitude is 1. Even though it's been multiplied by a negative, the amplitude is always positive, and then the period is unchanged. Okay, so 1, 2, 3, 4, 5. Let me put 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we're going to go from 1 to -1, and then -2 pi to 2 pi. Okay, so we've got it's cosine flipped about the x-axis is what this is. Right, every single y-coordinate, the value of the function has just been flipped. It's gone from, it was, if this was x comma y, then now it's x comma minus y. X coordinate hadn't changed, just the y coordinate flips. So, okay, but a period is 2 pi, so let's draw plot the main points. We've divided 2 pi into 4 pieces. 1, 2, 3. So here's the 4 intervals. So we start at x equal to 0. We're going to be at -1. And then we know at the end of the period, we're going to be the exact same point that we started with at the beginning of the period. So we'll be here. Okay, now we need to have 2 x-intercepts. So these are going to be the x-intercepts we can see. And then we're going to have a peak here at 1. Okay, so now let's just plot the graph. There we go. And there's from -2 pi to 0. Okay, the frequency is 1 over 2 pi. It's 1 cycle took how many x units? 1 cycle was 2 pi. And then the angular frequency, well, 1 cycle is 2 pi. That was how many radians around the circle to go 1 cycle, and what is that with respect to the x units? So it's just 1. Okay, y is equal to sine of -x. There's been no scaling of the function, no scaling about the y-axis, so the amplitude hasn't changed, and there's been no scaling of the x-axis, so the period hasn't changed. There's been a -1 multiplied, but there's no scaling. It's just multiplied by 1. There's been a flip about the y-axis. But the fact that we multiply minus by the x-axis doesn't mean the period's a -2 pi. Period's always positive. The period of the amplitude hasn't been affected here. Okay, but we're going to go from 1 to -1, and then 2 pi to -2 pi. Okay, now here's a full period from 0 to 2 pi. Let's divide this up into 4 intervals, equally spaced. Okay, now, so sine is 0 at the origin, and that's not going to change. Now, a flipping about the y-axis means you're multiplying all the x coordinates by -1. So if we think about the sine curve, flipping about the y-axis means we're doing this. We're taking this region and bringing it over here. So it's going to do, right? We've flipped this here, flipped this here. Okay, so with that, we'll be coming down here. So we'll have a peak at this first point. So this is going to go, the amplitude's 1, so we'll come to -1. Then we'll have an x-intercept here, and then at this point we'll have or this will be a trough down here, and we'll have a peak down here, and then an x-intercept here. So like that. There we go. Now the frequency is 1 over 2 pi, and the angular frequency is once again 1. Okay, cosine of 3/4 x. You can see the amplitude hasn't changed. Now the x-axis has been scaled. It's been stretched, scaled up, because it's been, each x coordinate has been multiplied by the reciprocal of this, so 4/3, which means the period has changed from 2 pi to 2 pi times 4/3. That's 8/3 pi. Okay, 8/3 pi around 8.4. Okay, now, so we'll make the far left and the far right tick marks of the x-axis maybe 3 pi. Yeah, let's do 3 pi. So, okay, and then we'll do, this is 1 -1. Okay, now, so we have 20 tick marks going from the origin all the way out. So each tick mark, if we divide this, or no, we divide 3 pi by 20, each tick mark is around 0.47. Okay, now, so let's see, 3 pi is what? Now, how far above this is 8? Is this above 8 pi over 3? Okay, now how many tick marks is that? A little over 2. So the period goes from 0 to, so 1, 2, and then about 0.2 to there. Okay, now let's divide the period. Here's the period going from here to here. Let's divide that into 4 equally spaced pieces. So this is, let's see, 1, 2, this is 10, 11, 12, 13, 14, 15, 16, 17, and then, so okay, 3 minus this plus 17. That's how many tick marks the period is. So let's divide that by 4. About 4.4. So 1, 2, 3, 4, and then not quite halfway. Okay, and then you add another, so that times 2, 8.8. So here's 8, so there's about 8.8, and then you add another 13.3. So 10, 11, 12, 13. So there we go. Now, we haven't flipped or anything, so we've got the cosine graph. It's going to start at 0. It's going to be at positive 1. Okay, and then at the end point of the period, it's going to be at positive 1. Okay, now this is going to be an x-intercept, this is going to be an x-intercept, and this is going to be a trough. Okay, and then this is not on the graph here. That's just the end of the period. So, okay, now let's draw the curve. Okay, now let's copy this. Okay, there we go. Now the frequency is 1 over the period, so it's going to be 3 over 8 pi. The angular frequency is going to be 2 pi over the period, so 2 pi over 1 times 3 over 8 pi, just 3/4. Okay, amplitude is 2, and the period has been scaled up by a factor of 4. So 2 pi times the reciprocal of 1 over 4 is 4, so the period is 8 pi. Okay, so 8 pi, and then we're going to go from 2 to minus 2. Okay, now let's divide the period up into 4 pieces, equally spaced pieces. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's the sine graph. So the origin we're gonna be at 0, and then we're gonna end at 0. The period. Now so we're gonna start going up here. There will be a peak at the first point, and the amplitude is 2. Then we'll have an x-intercept here, and then a trough here. Okay. There we go. And now there we go. Okay, the frequency is 1 over 8 pi, and the angular frequency is 2 pi over 8 pi, which is 1/4. Okay, cosine of pi x, the amplitude hasn't changed, and the period has been scaled down by a factor of pi. So the period is now 2. Okay, now we could just do the x-axis from minus 2 to 2, but let's think about the major tick marks are in radians. So, okay, pi is 3.14-ish. So, yeah, let's do pi to minus pi. Okay, then we'll be going from 1 to minus 1. Okay, so there's 20 tick marks from 0 to pi, so let's do pi divided by 20. That means that each tick mark is about 0.157. Okay, now pi minus 2 is that distance. Now, how many tick marks is that? About 7.3. So, okay, 1, 2, 3, 4, 5, 6, 7. About right there is where the period ends. Okay, now that is so 20 minus this. There's the period in terms of tick marks. So let's divide this by 4. So about 3.2. 1, 2, 3, about right there. Okay, that times 2, about 6.4. 1, 2, 3, 4, 5, 6, about right there. Now add another 9.5. So here's 10. So right in there. Okay. So we haven't flipped or anything. So at 0, cosine is going to start at 1. And then at the end of the period, it's going to be at 1. Okay. Now midway through, this is kind of confusing with this dot here because this is not going to be on the graph. So here's midway. We're going to be at minus 1. Okay, and then these are the x-intercepts. So, like that. Like that. So, there we go. We might be able to add another couple of periods in here, maybe. We could erase this. Okay, there we go. And the frequency is 1 over the period. And the angular frequency is 2 pi over the period. So 2 pi over 2 is just pi. Okay, so the amplitude here is 1/2. The period has been changed from 2 pi, and it's been multiplied by 2 over pi. So the period is now 4. Okay, so we'll go, this will be 1/2, 1/4, and then pi is 3.14, then 2 pi is like in the 6-ish range. So let's do 3 pi over 2. So let's see. 3 pi over 2. Okay, it's a little bit over 4. Now divided by 20, so each tick mark is that much. So now this minus 4 is what? Now how many tick marks is that? About 3. So you go 1, 2, 3. There's the period. Okay, now if we say 20 minus this, that's how many tick marks a period is. Now let's divide that by 4. So about 4.4 and a quarter. 1, 2, 3, 4. And then 8.5. 10, 9, 8. And then let's see. Times 2. And then plus another. About 12 and 3 quarters. So 10, 11, 12. There we go. So we've got the cosine graph that hasn't been flipped about any axis. So we at x equals 0, we start at the amplitude, and then we're going to end at the amplitude. And in the middle, here's the middle point will be at the other amplitude at the trough. Okay. All right. And there we go. Frequency is 1 over the period. Angular frequency is 2 pi over the period. It's pi over 2.